Hello everyone, welcome to the Flying Machine channel. When flying an aircraft, the pilot's workload is certainly very heavy. In addition to controlling the aircraft's flight direction and navigation, the pilot must also ensure the aircraft's stability. Furthermore, the pilot must maintain constant communication with the co-pilot and air traffic control, or ETC. Therefore, a technology known as fly-by-wire was developed to assist the pilot in controlling the aircraft's direction and stabilizing it during flight. What is fly-by-wire, and how does it work? Let's take a closer look. But before we continue, let's support the Flying Machine channel by subscribing and turning on the notification bell. Fly-by-wire is an aircraft control system that uses electronic signals to control the aircraft's direction and stabilize it during flight. Fly-by-wire technology consists of sensors in the rudder system and other parts of the aircraft, a sophisticated computer unit or flight control computer, and actuators to move the control surfaces. These three components are connected via a series of electronic cables that function as transmissions to operate the fly-by-wire system. In its application, fly-by-wire technology was first used in the military, specifically on the United States Navy's F-8 Crusader aircraft in 1972, followed by the Russian Sukhoi T-4 bomber. Shortly thereafter, the British Air Force implemented a hybrid system on its fighter jet, the Hawker Hunter. The fly-by-wire steering system was located in the right seat of the aircraft, while the conventional steering system was located in the left seat for the rescue pilot. Meanwhile, fly-by-wire was first used on a passenger aircraft on the Airbus A320 in 1984. In business jets, the Dassault Falcon 7X became the first business jet to use fly-by-wire technology in 2005. To understand how fly-by-wire works, consider the following analogy. When a pilot attempts to control the aircraft's direction, he or she will naturally make several movements on the steering wheel. These movements are received by sensors as input signals. These input signals are then transmitted via electronic cables to a computer for processing. The computer processes these input signals, taking into account various other parameters such as aircraft altitude, wind speed, and engine speed, resulting in an output signal in the form of a command to smoothly and stably control the aircraft's direction. This output signal is then forwarded to actuators connected to a hydraulic or pneumatic system to move control surfaces, such as the rudder, ailerons, and elevators, to smoothly and stably control the aircraft's direction with a high level of safety in accordance with the pilot's wishes. Fly-by-wire is highly effective when activated in conjunction with autopilot mode. In this mode, the aircraft feels like it can fly itself stably and safely without the need for pilot assistance, much like future aircraft equipped with artificial intelligence. Aircraft with fly-by-wire have a very high level of flight safety. This is because the fly-by-wire computer system works very closely to stabilize the aircraft and protect against any potentially dangerous activities or over-control during flight. A fly-by-wire aircraft will also not stall even if the pilot pulls the control stick and forces the nose up beyond the normal angle of attack. Another advantage of aircraft with fly-by-wire technology is their lighter weight compared to aircraft with conventional control systems. This is because the aircraft's control system uses fiber optic cables made of lightweight metal alloys. This increases the aircraft's carrying capacity and range. Although fly-by-wire is a nearly perfect modern aircraft control system, under certain conditions, the fly-by-wire system's performance is not synchronized with the pilot's wishes. This means, for example, If the pilot wants to aggressively tilt the aircraft to more than 67 degrees, the fly-by-wire system may ignore the pilot's command, tilting the aircraft only 60 degrees, ensuring smoother maneuvers and avoiding structural damage. Therefore, a high degree of discretion is required when controlling an aircraft with the fly-by-wire system. From this, it can be concluded that the core of fly-by-wire's performance lies in the flight control computer. So what if that computer fails? Will the aircraft's control system fail? Of course, this has been anticipated by the developers. Aircraft with fly-by-wire technology have a multi-layered protection system to mitigate system failures. For example, on the Boeing 777, fly-by-wire technology has 3 primary flight control computers operating simultaneously. If one computer fails, the other 2 can continue operating, thus preventing a failure in the aircraft's steering system. To date, fly-by-wire technology has been implemented in a large number of modern aircraft, especially those manufactured by Airbus, which is claimed to have the most stable aircraft control system with a high level of safety. That's the discussion about fly-by-wire technology on airplanes. If there is other interesting information about this topic, please write it in the comments column. See you in the next video.